MATLAB thinks it it's a one by one matrix of values. That's how it got its name, Matrix Laboratory. So now we are here for some statistical understanding. So we'll move forward with those after a few while. But for that, firstly, we understand what matrix and how to enter rows and all. So for that, we'll start with C is equal to 1, 2, 3. This is how we can enter a row. And if I want to do some operations over C, like I want to do sine of C, then I can simply write sine C. It will perform sine on every number in this variable C. The plus point of MATLAB is you really don't need to know about matrices, but if you have that, then it's a good thing. Now suppose I want to transpose of I want to do transpose of C. That means I want to change rows into columns, then I can easily do by writing D is equals to C. Oh, sorry, that's the one. Yes. Now you can see that the rows has been transposed to a column. And if I want to do some operation like D into C, then you can have this scalar or 2D matrix depending on the operations you are performing. Now, if I want to run it again, then you try this. Okay, so now this is something very important to know. Like if you just wrote x is equal to 5 and you want to execute it again, then if you are working in command window, you have to write x is equal to 5 again and for n number of times to which you want to print this. But that's not the case if you create a script. So if you'll create a script, you'll have an editor, and if you'll write x is equal to 5 over here and you'll run it, first let ask for the save. So you have to save this and it will have your results. So now you can you can directly execute your file again and again and again, and it will have the result rather than writing it continuously on a command window. So that's the basic difference in editor. It creates a file, but working on command line is like you're working on a live screen. So let's start with some basic statistical calculations. Yes. So for instance, I have a class which have some students. So I want to collect some of the grades, and so let's say I have some of the grades like grades 100, 91, 92, 85. Let's see some messages there. Wait for a while. I think yes, Chinmay.
Yeah, ma'am, I had a question.
Yes.
Could you please repeat how did you get to convert the row into column?
Oh yes, I did. I just perform a transpose. If you can see, we have a row C is equal to 1, 2, 3, right? And to perform a transpose, this is basically a command. It's C, your upper dash, or you can say apostrophe. So
Okay,
if you'll do this, you will have a conversion of rows to column.
got that. Got that.
Okay.
Thank you. Thank you.
Okay, no worries. Okay, so uh, yes, so we were on grades. So I'm just collecting some of the grades right now for performing some statistical analysis, right? So we have 100, 91, 92, 85, 40, 77, 92, 91, and 94. So now I may have 200 people in my class or maybe a much longer vector. Now I might need to know the mean. So let's go ahead and figure out what is the mean of the student here. So the function, where's my cursor? Yeah. So there's a function for that in MATLAB. Just write mean and your grades. And here's a mean. You passed vector grid into it, and now it will calculate the mean in the normal way. Perhaps I'm interested in calculating median for this class. So the function for median will be median grades. Please mind it, if you have wrote grade, then you should write grade. If you have wrote any of the variable name, you have to put that one. Any mistake on writing the incorrect name will create an error. So median is there. Now it's a good opportunity to do some of the other operations like sort. So if you write sort, you will have the sorting. Uh, it will order my vector from smallest number to the largest number. And if you can see, 91 falls in the middle here. That's why the median is 91. I think that's the definition for what median is. You order a list of number from smallest to largest, and median is whatever is going to lie in the middle. Whereas a mean is more of the calculated value where you add everything up and divide by the number. Next, we want to figure out the standard deviation because a lot of time mean is not that important. Well, it is, but it's not a complete picture without knowing what standard deviation is. So for standard deviation, the MATLAB function will be std and grades. So if you enter it, you'll have this standard deviation. Now suppose I want to add new grades into my vector. So how I can do it? Mm, yes, it's grade grades 2 mm, grades and few of your new values like 41, 51, 47, 16, 19. Very good. Okay. Now, whenever I go back and try to calculate my vector, uh, so let's see, I want to do a mean of this. And if you have work on statistics, you will know that you would expect a shift to a lower value. If you'll go for a mean, let's see, mean creates 2. So earlier our mean was 84.6, now it's 68.7. And let's see the standard deviation. Standard deviation 2. Okay, so earlier was standard deviation was 17.9 and now it's 27.9. It has changed a lot. It may be much wider. Which one? Yeah, the mean, because there are some few grades, mean have shifted to low, but the bell curve of standard deviation gets wider. That is, if you plot a normal distribution to the bell curve, so it will get more fatter. So now suppose I have some high achievers in the class, like grades 3, 100, 97, 95, 90, 96. Suppose we have, and we'll calculate mean and standard deviation of these. So grade 3, 96, standard deviation, grade 3. Okay, so you can see standard deviation is so tight because these grades are so tightly compact. That's why there is a difference. Now let's calculate the variance. So for variance, the MATLAB command will be um, where grades 3 and hmm, and so those who know statistics, they'll know the variance is simply a square of standard deviation. So if you want to check it, you can do it by 3.6712, which was our earlier standard deviation. If you'll do it square, what it's there, what will the value? Yes, if you can see the variance and the I mean the formula wise and the actual values are same. It's a square of standard deviation. So MATLAB has inbuilt commands for mean, standard deviation, median, variance, which you can use a lot in your everyday task. If you get any more advanced statistics, MATLAB has whole additional tool for, sorry, additional suite for that tool, which you can use to tackle your problem. Now something very interesting. Now come up with the plotting. Uh, where is the plotting? Yes. So basically, MATLAB provides numerous visualizations that are by default are filtered to one of the ones that are compatible with your data you have selected. Yes, you can customize these plot using both interactive and programmatic tools. MATLAB Plot Gallery showcase MATLAB's many visualization along with example that you can control your data. So for example, very simple plotting. Suppose I have X which specifies a range of X values, and Y specifies an equation, and I want to plot this Y. So suppose I have X which goes from -5 to 5. It's a range, and I have a equation which I want to plot, which is 2 into dot 3, and I want to plot Y. So basically, before moving forward, let me tell you what is this Y. Basically, Y says we have this, first of all, this X dot says for every value of X from -5 to 5. Now we have to cube this X, and once the result is there, then we have to multiply it by 2. So our equation will be 2 into X cube. So now if we plot this, okay, so this is the error, my bad. So we have to plot Y, and this is your plotting picture. Okay, so for you, and I know we are running off time, and I have a lot of stuff to cover. So to handle that thing, I have wrote few of, or you can say I have selected few of the examples for you. Like this is an example of how we can create a line plot. So I'll make you understand each and every line from this code. So basically we are firstly defining x, y1 and y2. This x is basically a range which says that value of x will goes from 0 to 2 pi with an interval of zero point 0.1 between each element. Y1 is cos x, y2 is sin x, and next we are going to plot a figure. That's why we have mentioned figure here. So this is basically a syntax statement for plotting. So this plot says we have to plot x with respect to y1, and it should be blue in color. That's why it's B. Next, we want to plot x with y2, and that too with red dash line. That's why we have mentioned this over here. And what is this? This is line width 2. That means the thickness of the line should be 2 point, or we can say till 2 point. Now, these are basically a decoration material for the plot. Basically, we want grid to be in the background, and we want axis. So the first two is x-axis, that is it will go from 0 to 2 pi, and the next two are the y-axis, like from minus 1.5 to 1.5. And the other one is we want a title that will be trigonometric functions. We want x label to be an angle and y label to be a sine x and cos x. So if you'll run it, you will see the picture. Mm, yeah, you can see we have two graphs with respect to cos x and sine x. And the first one is with red color.
Excuse me, we are not able to see the graph, the
Okay,
plot. Yeah.
now,
Even the last time when there was a figure you said, it
yeah,
wasn't
yeah,
visible.
it wasn't visible.
No,
Okay, let
ma'am.
me check it out. Let me check it out. Mm,
Perhaps when you're changing the screen, it's not showing. I'm
okay,
not sure.
okay, wait for a while then. Let me
Sure.
see. Uh, um,
Ma'am, actually, you have to share your entire screen.
yeah, actually, I did. That's why I'm just wondering what's happening. I already did. Uh, just wait for a while. I'll no. Yeah, I'll do it again if it is possible. Can you share? Oh, yes, yes, yes. Here it is. That's good. Now it's visible.
Yes, ma'am.
Oh, that's great. So that's the first graph we just plotted.
Okay. Thank you.
I hope you have the commands for it, right? The first graph, this one, and the code we just did to, right now for line plot.
It's visible, ma'am.
Yeah, it's visible. Okay. Okay. So now you understood what it is. It has grid in the back, and yeah. First one is a blue color. Sign is in the red dash. You have some labels on x-axis, y-axis. You have a specific, you can say axis values from 0 to pi and minus 1.5 to 1.5. I hope it's clear. Now we'll move forward with another, you can say plotting, that is basically a function plot. So if you can see, for function plot, you have a statement, you can say you have a syntax f plot with at the rate x, which says whatever the value for x will be cube out, and it will goes from it has a lower limit and upper limit of -2 to 2, and we want it in red color with width 2 points, and then it's a decoration, x label, y label, and title. And if we'll run it, and definitely I have to share it again, uh, new share, yes. Oh. You can see, minimize. This is our new graph array. Uh, hmm. So this is our new function plot with y is equal to x cube. Here we haven't decorated mode, just we have wrote the title, x label, y label, and that's it. All the x-axis and y-axis has been automatically plotted by the MATLAB, because MATLAB is basically, in my words, it's a smart language. Half of the work it do it by its own. We don't need to mention every and each thing to it. So the next program which I have opted for you is again a function plot. Basically, if you want to plot multiple graphs together, so for that, firstly you have to specify the range. For function plot, you have to use hold on and hold off. So this is our equation which we want to plot, and that too with 2-point width. Then x, sorry, sine x minus pi by 5 into, you can say dash. The second specifier, yes, red dash, and with circle marker, that's why it's O. And the third one is sin x with just a dash with cyan color. So basically we have wrought hold off here because hold on retains plots in current axis so that new plot added to the axis do not delete the existing one. That means if we don't go for hold on, means on the first plotting, once the second plot is there, the first plot will be overwrote. We don't need that. That's why, excuse me. That's why we just wrote hold on after the first equation, and we wrote hold off till the last equation we want to print. So I will print it. I have to share this. Mm,
Hello.
hello.
Good morning, ma'am.
Yeah, good morning. Who's this?
Ma'am Geeta,
Yes.
co-chair research scholar. Ma'am, we are doing it first time. Please, आप थोड़ी सी स्पीड स्लो कर लीजिए.
Yeah, sure. No worries.
And please
So,
repeat it once again. Plotting.
uh, which plot I should repeat for that for you?
मैम जो प्लॉटिंग आपने ये बताई है ना फंक्शन प्लॉट्स.
Can
The
you speak
first one.
English?
Yes, ma'am.
All speakers are from the international. Okay.
Okay, ma'am. Ma'am, please
Uh,
repeat it once again.
this one, the first function plot we just studied, right?
Yes,
Uh,
ma'am.
oh, okay. So if you can see the first plot, for simple line plots, you just need a syntax plot and whatsoever you want to plot. But when you are working with function plots, your syntax will convert to f plots, and here you have to write your function. So for what it says that for every value of x, you have to cube this because it's a function, and that the value of x will you can say will be from -2 to 2 because it's a range, not a range, basically a lower value and upper value, and it should be red in color. That's why we have specified red, or you can say R. And then finally we have added labels and titles, like X label as X, Y label as Y, and title whatsoever you want to write. It just completely depends on you. If you will run it, mm, yes. Can you see this?
Yes, ma'am.
Oh, sure. Okay, good. So this is what we have just uh, plotted. It's y is equal to x cube, the simple equation, sorry, simple function. And what I was saying is, earlier we described the x-axis, y-axis by ourselves, but MATLAB is a smart language, so we don't need to. But basically, I don't need it because I can manage everything. But if you want to, you can specify the x-axis as per your need. But MATLAB automatically can also generate some of the stuff for you. So the next plot which we were on is multiple plots if you want to have. Like if I have three of the functions, sine x plus pi by 5, sine x minus pi by 5, and sine x. So here we are plotting three sine waves with different phases. For the first wave, we use a line width of 2 points. For second, we specifies a dashed red line with circle marker. That's what I was saying. This is basically the picture, that too in red color. And the third specifies a cyan dash dot, you can see, with asterisk mark line. If you'll run it, you can see the picture. I don't know if it is visible. Is this visible?
Yes, ma'am.
Okay, it is. Mm, yes. So if you can see, the first is simple blue color line. The second one is dash dash circle marker in red color. We haven't mentioned any line width. That's why it's thin in size in comparison to the blue one. And the third one is dash dot asterisk mark in cyan color. So what I was saying, we have just wrote hold on and hold off. Let's suppose we just comment it. So basically to comment, or you can say to mention any comment in MATLAB, you have to just put percentage mark in front of that line. So if you'll run it, see what you'll see, what you'll have. You'll have just a picture, this one. So because the first two functions you have just wrote, sorry, the first two function like line width 2 and dash dash, that red color line has been overrode by the cyan line. So we don't want that. That's why we have just mentioned hold on and hold off. So when you will run it, now you can see you have all of the three sine waves with you. So the next plot, which I have selected for you, is subplotting. So basically, this first of all, before understanding this, we should know what the picture of output is. So then you will better understand this code, because you just told me there are some of the new people who haven't worked in MATLAB yet. So it will be better understanding for you. So if you will run it, let's see, is it visible? No. Mm, yes. Yes. So this is basically an output of this particular code. I have selected this code because in upcoming years, when you're going to write your research papers, this will be a very helpful picture for you, or you can say plot for you, because majority of the time to display your outcomes, student use this. Basically, I even use that too. So I think it's a bit important one to understand, sorry, to learn. So what this basically picture is about, you can say the code is about is, firstly, we have our TB data, which have some number of rows and columns. Then we have measles. This is basically a row. We have mumps. We have data for this, and we have chickenpox. We have data for this particular information. So what these three lines are telling us, it says that in TB, for any number of rows, sorry, in TB, for any number of rows, the first column will be the years. That means this 1990, 1991, 1992 till 2007. These are basically represents the year. Then comes TB data, and for any number of rows, the second column will be the cases. That means this 4889, 5273, these all are describing the cases. And TB, for any number of rows, the third column will be rate. So like 16.4, 17.4, these are basically represents the rate. If you don't understand what basically this data TB data was. That's why I have just make you understand what each of the number represents. So now we want to create multiple charts in a single picture. So to do that, for the first chart which I have created for you is pie chart. We want a figure. That's why we have just wrote figure over here. So the first is subplot. This is syntax for subplotting. Like if you want to plot multiple charts in single picture or single figure, then you have to specify the location on which location you want to plot that particular chart. So subplot 221 says that we have two rows and we have two columns, like 2 by 2 matrix, and we want to plot the upcoming figure on the first point, like where the pie chart is basically present. So next is directly write the syntax for pie chart, and it is like pie, some measles, some mumps, and some chicken pox. Just we have wrote the things which we want to submit, and then we have to mention each of the section of. Then we have to write the name of that section, like measles, mumps, chicken pox, and then you have to like title it. So we have just wrote childhood diseases. The next is bar chart. So basically we want its location to be on the top right. We will just mention that particular thing in your subplot, this particular line, like 222. I hope you understand. Okay, now like 2 rows, 2 columns, and that too on the second section of, you can say, the block of the division. Then the syntax for, okay, so so for this bar, I want the x-axis to be run from 1 to 12. If you can see on the picture, it is from 1 to 12. Then the basic syntax which I have created, I have divided each of the values by 1000 so that I can easily plot it. It's completely on you to which you how you want to plot it. And then uh, okay, someone has raised their hand. Whosoever is, go
Yeah,
ahead.
yeah, ma'am, this is Bhaktina. Just I have one query. So, like, we have other tools like SPSS, RStudio to calculate the statistics or to study the statistics. Here we are using MATLAB. My question is that if I have data in Excel sheet or if I have data in SPSS,
Uh-huh.
yeah, is there any way to link Excel to MATLAB so that I can just copy the data and make the graphs here, or else I need to add, every time I need to add all the data manually because
Oh, uh-huh. Okay. Are you
yeah,
done?
that's yes,
Okay, dear. So listen, the thing you are asking is a thing which I'm going to cover in next hour. So don't worry. It's just a basic introduction right now, which I'm working on, or I'm just telling you about, because there are people who are very new to MATLAB. But the thing which you are asking will be the last thing for the day. So don't worry.
sure, ma'am. Thank you.
Okay. So just be patient is the first key for the PhD. So don't worry. Uh, okay. So where were we? Yes. So this we were on point 0.5 stack. This point 0.5 stack basically tells the thickness of the bar. So suppose I have just reduced this to 1. Let's see what will be my result. Okay, new screen to share. Okay. Wait. Okay, so this is my new screen. If I, okay, God, this thing. Okay, so this is my new output. If I'll reduce the stack to 0.1, if you can see, the thickness had reduced to immensely down. That's why I have just wrote 0.5 here so that I can have my desired result with a specific thickness. I hope it's clear. So now some decoration. X-axis with months, sorry, X label by month, Y label by cases in thousands, title with childhood diseases, and axis from 0 to 13 and 0 to 100, just to mention it. Now we have the third chart, that is a stamp chart. We want on the third location, that's why I have wrote 3 over here. And it's basically a very simple chart. We just need the information we want to plot. So simple, write years and cases and anything else what you want to plot, and then just do some decorations, X label, Y label, and title, and specify the x's. Like I want an axis from 1988 to 2009 for the x-axis, 0 to 6,000 cases for the y-axis. Now the last one is your line plot, which we just did in the previous, or you can say the first first plot we just did, the line chart, line plot, and I want that on the fourth section of my figure. So I just wrote 2 to 4, 2 rows, 2 columns, and the fourth section. Plot what you want to plot. Years and rate, go ahead. Write years and rate. It will pick up a data from your above mentioned information. It will directly plot it, do some decorations, and you are done. Like X label, years, Y label, infection rates, title, tuberculosis cases, and X's will run from 1988 to 2009, and Y will run from 5 to 20. Okay, these were basically the things for plotting. These are the very limited example because we have very limited time. But if you want to see some of the more examples, you can see this from here. This is basically a very official MATLAB, not official, but public, yes. Public MATLAB plot gallery. You can go ahead. I have just picked up these examples from here only, just to make you understand how it look like. I'm showing you this particular thing. Um, yes, these are some basic examples from which you can pick it up. Let's suppose, yes, we did work on this. Yes, uh, that would be like good. If we'll click on view source, it will open it. Oh, don't say this is a nine. Yes, so go simply on example. You'll have your code. You pick it up, run it. You will see uh, how it's work. It's basically error-free code over here. You can just go and study it. Second thing which you should understand is MATLAB has very strong documentation. Everything you want to study, don't go on Google, directly go on MATLAB. MATLAB has everything. Even if you want to know what plot function is, click the plot and you will see. Oh, I think this is a new screen to share. No, thank God. Thank God. Okay, so plot has different syntax with which you can work, and each syntax has specific example with it. You just read the stuff, see the examples, and you are everything here. You don't need to go anywhere on Google. That's why I like MATLAB personally. So, so, some serious stuff now. This was just a game, just to make you understand, to make you comfortable with MATLAB. But now, some serious stuff for which we all are here, and maybe you are going to use in your upcoming researches. Uh, we have talked about MATLAB, basic stuff. Now we are going to talk about MATLAB and environment for data analysis and visualization. You look at we'll look at how we can import no yes okay how you can import data into MATLAB and analyze and manipulate that data. Please excuse me, I'm very thirsty right now. uh, okay, Narayana, go ahead. uh, do anybody need to ask any question? Okay, so now we'll understand linear regression in MATLAB. Uh, we'll understand linear regression in MATLAB, fit distribution of data, curve fitting of data, and most importantly, to understand how we can. Hello.
Ma'am,
Yes.
ma'am,
Yes.
in TB data, you have, ma'am, there at,
Sorry, sir, you are not audible.
ma'am, am I audible?
Yeah. Go ahead.
Madam, in TB data,
Hmm.
there at the end, first fee,
Yeah.
what is that particular meaning, ma'am? Measles, mumps, at the end of square bracket, you have a first fee. What is that meaning?
Basically, it's yeah, it's basically, I think it's an error. Let me check it out. It should not be there. Oh, yes. Basically, it says that we want this data to be used with the other stuff we are working on.
Okay,
Okay.
like importing data above.
Yeah. That not that importing data. It's like we are not importing data is basically from the other files you are working. We are on same page right now, or you can say we are working on like editor. We are not importing file from the other directory or something else. This apostrophe basically says that you have this data along with the other one. They are interlinked.
Okay. So
Okay.
which means it is in current page, the data is available in current page, you can get it from it.
Not current page. No. That means like the TB data is basically linked with the measles, mumps, and chickenpox. They are not the two different sections. These are the basically one that has been presented in two different ways.
Okay.
Okay.
Thank you.
So it's okay. No worries. So now where were we? Now we'll understand linear regression in MATLAB, fit distribution of data, curve fitting of data, and most importantly, to understand how we can import data from Excel and analyze in MATLAB through an example. So first of all, there is something like we'll work on curve fit. Okay. So where is my Excel? Yes. So what we are going to do is curve fitting toolbox provide interactive tools and command line functions for fitting curves and surface to data. The toolbox let you interactively explore relationship between data, generate predictive models, and conveniently use and share your curve fit. Post-processing analysis include prediction, forecasting, calculating integrals and derivatives, and estimating confidence intervals. So for today, what we are going to do is our first task is to initialize this model, which is there, and use this to estimate A and B based on the following data, which is there. So how we'll do this by curve fitting? We'll go back on our MATLAB. First of all, just clean everything. This is very busy stuff right now. So clean it by writing this, this, and close this stuff for now because we don't need it. So yes, it's all done. Now it's clean, and we'll start with some new and interesting things with curve fitting. So to do this, basically, I have to enter my data. So I'll do it by x is equal to 0.1, 0.2, 0.4. This is the same data which I've just shown you in the PPT. 6, 9, 1.3, 1.5, 1.7, and 1.8. And then y value 0.75, 1.25, 1.45, 1.25, 0.85, 0.55, 35, 28, 18. Cross check. Yes, enter. Now let's estimate the data. Let's click on the curve fitting tool. Where it is? Apps. Curve fitting tool. Okay, so this is basically a GUI for curve fitting. Simply assign x, y values which you have. So we'll assign x as x, y as y, because we have just mentioned it in our command window. Yes. Okay. So now we're gonna go and select. So basically, this is a polynomial figure for that data we have entered. But right now we have our customized equation with respect to we have to work with. So we just write custom equation and we have to mention our equation. It will be a the equation which I have just mentioned you over here. I don't want to full screen it every time. That's why I'm just doing this. Apologies, but you have no other option. Okay, so this will be our equation, or you can say, yes, this is the equation for which we want to work. A x exponential b bx. So for that we have to write it a x exponential with the positive one. We don't want any c. So this is basically our equation. If you want to rename it, you can rename it.
Ma'am,
Yes.
I can't see where you are writing this equation right now. I can only
Oh,
command window.
okay. Oh, I'm so sorry. So sorry. I think now it will be visible. So sorry. Thanks. Is it visible now?
Yes, ma'am. But how did you open it? We don't know
Yes,
that.
ma'am.
Okay, don't worry, don't worry. I'll let you know. What I did is just close all these things. Okay, so what I did is I just clicked on this curve fitting over here, that in MATLAB itself, and this particular window was open. Okay, should I do it again? Like it would be like more easy for you? No. Curve fitting. Okay. Now you can see. Now you can see this window.
Yes, ma'am.
Okay, so we'll start from here. Okay, so this basically a simple GUI for curve fitting. As you can see, we have just mentioned x and y values over here. So we'll directly drop down it by x as x and y as y. So for these particular datas, the polynomial figure has been automatically generated by MATLAB, but we have our predefined equation for which we have to plot, which is there in your, I have just mentioned you in PPT. So I have to write this equation over here. So firstly, customize equation, you have to select it and you have to write your equation over here, like a into x into exponential b into x. So if you write this, so MATLAB will automatically fit that equation with the data, and you can see
Ma'am, here we haven't defined B yet.
b is basically a and b are the variables which you have to find the value for, the coefficients. That's the only question. We have to find the value of a and b with respect to these data. So that's the thing MATLAB will automatically will calculate for you. If you can see on the left hand side, we got a coefficient a 9.8 and b as minus 2.532. We have also got 95% of confidence bound of these estimates. Basically, that was all for the curve fitting. It was very simple tool for you, and we are going to use that for the real-time example as well. So I'm closing this for now. If you have any question for this, ask me. Otherwise, I'm gonna close this window right now. Okay. Um, okay. So the next thing we have to understand is fit distribution. So now I'm going to go over how to use the distribution filter in MATLAB. This is a tool that MATLAB has to fit distribution function like PDFs and CDFs or even other options to data. If you have data that you want to fit a distribution to, you can do that actually very easily in MATLAB. For understanding this, MATLAB has few sample data set that will automatically load it into it once you will download MATLAB. One of them is cars mall and has some information about 100 different cars and the variables we are going to look at and fitting a distribution. Today we are going to fit a distribution for miles per gallon, you can say MPG. I'll let you know how what it is basically. So if you load um, cars mole dataset, which is already there in MATLAB, so you can see on the workspace you have different information about that cars mole dataset. Complete information has been imported over here. So we are going to work on MPGs today. We're going to distribute our distribution filter on this particular thing. So now once we have load our cars mole, we'll directly go to distribution filter. Here it is. Is it visible?
Yes, ma'am.
Okay, good. So this is the distribution filter GUI. Basically, all the commands for fit distribution, which you are going to perform over here, you can write that on window as well. But I think working on GUI is pretty easy. So the very first thing is to load the data. Load the data. If you have loaded your data into the workspace, which we have already did, then you just have to show up by click on the drop down window and select the variable MPG in this case. Now I'm not going to change any of these other options, and I'm going to click create data set, and we have not fit any of the function yet to our data. So the first thing that will show up is a basic histogram for this. It calls its density over here, if you can see on the top. But it's more like PMF, that is probability mass function, rather than a PDF, that is probability distribution function. And we are going to fit two different functions to show how you guys what a good fit for this distribution would look like. We are going to click on new fit, and then this window will open up. You can create a bunch of different fits and give them their own name. We already have loaded data over here, and then yeah, it's a normal one. I just need a normal distribution right now. We have different options which you can select from, or you can say the different families of probability distribution that you can fit your data to, but I'm right now working with normal. So if it's mostly parameter.
Ma'am, we can see your new screen.
Oh God, this. There it is. Okay, so where were we? Have you seen this picture?
Yes, ma'am.
Perfect.
Yes, ma'am.
Okay, so this was not visible to you, right?
Yes,
Yes,
ma'am.
ma'am.
Yes.
Yes.
Okay. So when I'll do it again. If you'll click on new window, I think a new screen to share. Yes. Uh, so this window will open up. You can see the pop-up, and yes. So this window will open up when you will click on new fit. Okay. Here you have different options from different probability distribution family, which you can use for your fit. So it has mostly parametric, and then if you ever want to work with the kernels, like if you go for non-parametric, you can work with kernels, which I'll show you later. But right now I'm going to select the the normal one, and I'll apply it. If you can see over here, the data is more or less bimodal. So it has peak over there in 15 to 20 range and in 25 to 30 range, which is basically, I don't think is the best fit right now for this particular data. So if you want to see more of the example of this, like why I'm saying this is not a good fit, you can see this. You can also check it easily because you can also go for probability plot chart, or yes, it's similar to the QQ chart. You are telling here also what I'm telling. We are telling it here what kind of distribution we want to plot it against. All these points are our data, basically a miles per gallon data set, and we want it to fall on this red straight line. And if the point don't fall on this red line, then it would be a good.
Excuse me, ma'am.
Uh,
Ma'am, I'm trying to connect from another device, and he's waiting for the meeting host to let me in. Please, can you, if you can do that?
so what should I do then?
He's saying the meeting host will let you soon.
So sorry, sir, but you should call Dr. Meenakshi for this particular thing.
Okay, okay, thank you. Thank you.
Is this screen is visible?
Yes. Yes.
Okay. Okay.
Yes, ma'am.
So okay. So these little points are our data, basically the mile per gallon data set, and we want this to fall on this straight line. And if these points did fall on the red line, then it would be a good sign that data is actually normally distributed. This is the idea with probability plot, or you can say the QQ plot. But as you can see here, there are some cases, especially on the tails, the data is really not normally distributed. So let's go back to our PDF, or you can say density. So I'm going to create another fit, and you can manage that with manage fit. So the first one is we'll create a new fit. We have number of bunch of different sections. Now I'll click for the non-parametric. Now I'm going to show you what it looks like with kernel. Again, I'm not going to
Ma'am, that window is not visible after you click new fit.
It should. God. I think now this will be visible. This is the new window I'm working on right now.
Yes, ma'am, now is.
Okay, so the where we have opted for normal distribution, now we have opted for non-parametric. And if we'll, I'm not going to specify any of the thing. I'm just going to let it decide the bandwidth automatically, and will put a little dent on the distribution because it will look at our.
Problem is with your network. Don't disturb in between. If window is not visible on your side, it means problem is with your network. Sorry, ma'am. Sorry to interrupt.
No, sir. It's okay. Actually, that's good because I'll understand where we are lacking behind, because my purpose is to make them understand everything, and it will be okay. Don't worry.
No, your window is visible, ma'am. It's very clear on my screen, but maybe some issue with their internet. Okay, so it's not fault from your side. That's okay.
Okay.
Sorry.
Continue, Dr. Bhavneet. You continue. Everything is visible.
Yeah, sorry.
Okay. No worries. No worries. Okay, so if you can see, we have just plotted two plots over here for fit 1 and fit 2. One is normally and one is non-parametric. And if you can see that there should be a dent in 15 to 20 range and 25 to 30 range, which was easily understood by the second, that is the non-parametric one. So we want to, that is actually a good fit. So we'll manage our fits by clicking on manage fit. So this window has been popped up when I clicked on manage fit. This window popped up, and I want my non-parametric distribution to be displayed on the screen because it actually fits our data as per my need. So if you can see, the first one has been removed and the second one is there. So basically this was all for the distribution filter. I think you can play around with a lot, and it will also be easy to use if you want to show how you can distribute your data as per your need. So this was the two basic things which was important from the statistical point of view. Now, the thing which some of your guys just said, that how we can have our data from Excel and how we can work with MATLAB on it. So that stuff is gonna start. So I don't know who that guy was. So please prepare. Please be like, have your concentration over here now. So before that, I'm gonna close all these things, these extra windows. Okay. So the next thing, some of the, you can say, information about things. Now I'm going to tell you how to access data from spreadsheet, or you can say Excel, because as you have just told, you store your data in Excel and you should know how you should access that from there. Then I'll now in upcoming time, how much time is left now? I think, oh my god. Okay. So okay, so now after that, we'll plot the data and customize the figure. Then we'll perform statistical analysis and fitting on that particular data, which we'll extract from the Excel. And then we'll automatically generate the report to document for analysis. Now, regardless of whether you are working in Excel, MATLAB, or any other platform, we found that each of the platform carries same workflow whenever they want to analyze data. So the very first phase is the access phase. It is to take out your data where it is into the environment in which you want to start working. Wait for a while. I think there is some issue. Wait for a while, please. I'm gonna stop a video for a while, then I'm reconnecting it.
Okay, ma'am, no problem.
Okay, so am I visible?
Yes, ma'am.
Okay, great. So where were we? We are on access phase. So it is to take out your data where it is. It can be an Excel, binary file, text file, or multimedia file. It can come from different databases or variety of hardware. So the next phase which we'll understand is explore and discover. So it is a phase where you're going to spend your majority of time. Here you're going to plot your data. You can perform modeling, and you may put some interactive user phases also. But your work is not valuable if you're not able to share your work with other people. So this turns on to the third phase, that is the sharing. So here you can share your task performed in a different formats. So today, demonstration is depend on, okay, so yes. So the demonstration is dependent on modeling global solar radiation. Idea is to tell how much sun's radiation should hit the Earth's surface. This is a problem in many areas, such as designing of solar pallet systems. A properly designed system knows how much electricity the solar cell will give and for which how much. So how, we must need to know how much solar radiation we need to expect. As we know, solar radiation is not essential thing to measure. That means there are many parts of the world, like developing countries, where there is no history of measuring solar radiation at the moment. So a properly designed to properly design our system, we need to find some ways to predict what will be the solar radiation measurement can be there, so that we can predict how much electricity we can get, and we can design our system, or you can say design our system properly. Yes. So there are many different ways we can model solar radiation, but we have picked this equation, that equation which is there on your screen. Uh, don't worry about this too much. Even I have picked it from an article only. Here H gives me the relative humidity, delta T gives me a daily temperature difference, and RS gives me the solar ratio. So the workflow we are going to go today is a real world data from weather station Davis, Delhi, California. Is there a new screen to share? Oh, oh, but why? Okay. Is it visible?
Yes,
Yes, ma'am.
Okay, okay, great, 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 great. Okay, so where were we? Yes, our workflow is from Davis, Delhi, California, where they measure this H delta T, and they have some fancy model to measure the solar ratio. So now we are going to put values of RS, H, and delta T, and we will fit this model and will get the estimates of these four coefficients A, B, C, and N. So if we'll get good fit, then we can take this model to any new H and delta T for prediction of solar ratios, and can predict how much electricity we can get from solar cell and can design our systems properly. So this was the high level idea what we are going to go now. So the very first step for today's task is access phase, that is how to get data into MATLAB uh, so that we can start our work with. So we'll go back to our MATLAB where we are. Okay, firstly clear all. Okay, so now okay, I have just removed that from here. Yes, this is the thing. New share. Okay, so so here you can see I have my required file Davis Delhi, that is an basically an Excel file. So I will right click it and open it in outside the MATLAB, just to see what is there in this stuff. Okay, now this is a new one. Okay, so This is basically your Excel file from which we can collect the data. We have to collect our data. So this is just to make you show what is there in this data, or I mean in this file. So so the thing is, we have to plot our data, or we have to import our data. So for that, we yes, here we are. We'll click on import data. Import data is used to import data from any source to MATLAB and to perform some customizations on it, basically. So here I'm going to select it and wait for a while. It will open it. So the file which has been opened is this one. Okay, so what we have to do, I'm going to select the data which I need for today's work. So the very first one will be date, day of year, max air temperature, min air temperature, relative average relative humidity, and Sol ratio. Yes, so you can drag up and down for how much data you want. And now select the output type. I want it in a column vector.
What is
Solar ratio, which is there in your PPT as well. Solar ratio is basically,
you have shown some formula, right? That is what.
yeah. We have just pick up our variables from that formula itself.
Okay.
Yeah. Okay, so I'm gonna check it and see, does they import in our MATLAB? Yes, if you can see in our workspace, the data which we have selected from our file has been imported into our MATLAB, and you can see its size. It's 3652 by 1, that is 3652 number of rows we have for that particular one column, that is relative humidity, relative average relative humidity, and so on to Sol ratio. Okay, so firstly, I have let's start with some basic plotting just to make you comfortable. Let's see. So let's see if I want to plot for Sol ratio. So for that, I'll click on Sol ratio in a workspace and go on plot, and then simply line plot. Let's go for the simple line plot. So this new screen is popped up. This is basically a Sol ratio plotting for you. If you want to study this, you can simply go by zooming. You can zoom in, you can zoom out. You can use a pen or a hand for moving here and there. And even you can check out a cursor value on a specific location, or you can see on a required point. Like this, you can keep exploring different kind of plots for visualizing your data. If you can see here, yes, if you can see here on a command window, MATLAB is automatically writing command for you when you click on column name and the what kind of plot you want to see. Isn't that great? It's working automatically. You don't have to write a long commands for these stuff. Okay, so now let's dive into some more complex 3D plotting. So for example, you want to plot your data. You want to plot, you want to plot your day of year on x-axis, actual year on which measurement was taken on y-axis, your solar ratio values on z-axis. I was hoping a question, but it's okay. If you can see, you don't have data that will show the actual year on which measurement was taken. So now we have to figure out what command MATLAB uses to pick out, or you can say pick just the year, because we need year. So we don't know it right now, right? So what you can go to MATLAB and you can ask for help. So help section is there for documentation. Now simply write date and see what is there. MATLAB has given you some of the options with the name date, from which you can opt as per your need. If I'll go convert date time vector, if I'll go over here, like I'm gonna click this. Let's what's happening. Not work. Okay. Uh, hmm. When we click on date vec in our search documentation, this window popped up, which tells like what is date vec, what are the different syntax you can use, and for those syntax we have specific examples also. If you want to read this stuff, you can go and read it. MATLAB has lot of functions, and you can say a data or variables, everything is there. So if we'll go and see some syntax, we can come up with which syntax we want to use for our example. You can see the last one, date vec return the component of it. Okay, I think this one is what we are looking for, the last one, this particular one. So we'll go on MATLAB and we'll write our information for that. So we'll write year tilt 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 tilt. So what this basically tilt is, this means we don't care about what else is there. If you can see in the documentation, we have M, H, whatever, like month, year, date, hour, minute, second, everything, but we don't need it. We just need year. So we'll write year and everything else will be tilted. And we'll write our function, that is date vec clearly. Before that, we have to click it. What's there? Oh, year. Okay, 1, 2, 3. Okay, and date vec date. Okay, let's see. Oh yes, just see in your workspace we have a new entry over there with the name year. So now let's go and have a plotting. Now select what we have to select, day of year, and then sole ratio in workspace. And mind it, it should be in the order which you want for X, Y, and Z axis. So you can see on the basis of reading, on the basis of on the basis of selection we made, MATLAB has generated some of the options for you. Let's select scatter 3. Okay. So this result is showing a base reading, which is difficult. So we have to customize it for better understanding. So for this, either we have to write some code, or we should go for, we can select for show plot tool. If you'll click it, new window. If you'll click it, Wait. Okay, if you click it, this window will pop up. Okay, hope it's visible to the scholars.
Yes, ma'am.
Okay, great. Um, yes. So, mm, so basically, this is an interactive environment where we can make any customization which I want or which we want. So I'll start picking up my options on plot browser on the right and select the data. And now we'll go to the property editor down there. And if you want to change the marker, we can change it. Like if you want to have X, you can have that, but I'm very okay with this circles. I'm not gonna change it. And now let's figure out some of now let's give this figure some sense of understanding. Now rather than giving it same color of monochromatic blue, I'll color each point relative to its value in a variable from our workspace. So now I'm going to color each point here according to its value in sol ratio. You can say solar ratio. So in the color section down there, we have to select the variable with respect to you want to show the color. So I have selected sol ratio. It should have changed its color till now. I haven't changed the color. Oh yes, let's see. Now color has been changed. Now you can see each point is colored according to its Z value, which make it much easier to tell what I'm looking at particular time, where it is in 3D space, higher on Z axis or it's lower on Z axis. Now if I want value these color, if I want to see what value these colors are associated with, then I can opt for, or you can say I can select a insert color bar, which by clicking on this section will be displayed on your screen. Okay, so this property editor have shown some commonly used properties, but if you want to see some other options, you can go for the more properties and a new window to share. Where it is. If you see more properties, you can have this particular section and you can just see whatever you want to see other than the basic things which has been presented. Okay. So now let's modify the axis as well. So we'll go on axis. We'll rename it. Okay. Y-axis by year and Z-axis by sol ratio. Similar to data opt here. Also, you have some options like as you have more properties in data, you have more properties for this axis also. And you can see the same. Oh, I have to screen share that again. Okay, where were we? These are the more properties for axis. If you can see on the top, if you want to opt for any of the one, you can go ahead and you can choose the one. now where were we? We were here, and we had just named our x's. So in this window, you have many other options, like for better presentation, like you can add some subplots, lines. You can change the color map, like here, which is there. I have selected the jet one. And you can change the background as well if you want to.
भाई साहब सब काम एक मिनट
Do you have any question?
एक मिनट होल्ड करना बस सर
Should we continue?
Yes, ma'am.
Yes, ma'am. Yes, sir. Yes.
Okay. Okay, so where were we? Okay, we did all these stuff. So now it seems okay, and we should move forward. So select hide plot tool. And you can see the complete picture. You have and very readable customized plot. And let's see, it's in 3D view. So for 3D view, you have to select it and you can rotate it beautifully and you can see whatsoever you want to see. Now we can see the axis to a specific, or you can a particular, we can see a particular axis too. So for that, we have to right click and we can go on the axis we want to see. Like, let's suppose I want to see XZ view. So this is the one that is, you want to see day of year with respect to the ratio. So it's there. You can see some pattern emerging here, like in middle of the year, soul ratio is constantly high, that is orange in middle section, whereas in winters, less sunlight is hitting the ground, if you can see on the bottom of both the sides. Now if you'll close this window and you want to see this figure again, then
sorry to disturb you here. Here, how you came into a conclusion that in winters is showing the same? Because see, this ratio is about the soul ratio versus the year, right? So how you concluded that it is in the winters or summers? Like, how do you accept
so
that?
basically year like days of the year, we have January to December,
right?
And in the distribution of two end of the year, you have the winters, like a cold weather. That's why. Common sense. Okay, so no worries. You just I'll give this stuff to you. You can go ahead, you can read it. Maybe you'll better understand it, because on the live session, there may be some of the cases or some of the times when you don't understand it in one go. But when you will study this again and again, definitely you get to know what I was saying. So don't worry. Thank you for the question. Okay, so where we were, so you can mute yourself, sir. Okay. Okay, where were we? Okay, what I was saying, if you close this window and you want to see this figure again, then you have to go and you have to perform all those previous steps again. But there is another way also. So for that, we can generate the code. Like from file, we can generate code. And I hope this MATLAB window is visible. Hello?
Yes, visible, ma'am.
Okay. Thank you, sir. Thank you. Okay, so if you can see, when I clicked on generate code, this particular code automatically generated in our editor. So the very first thing is you have to save this before doing any other thing on it. So I'll save it. Now I can do what I want to do. So this is a complete command you need, but you have to edit the variables with which you can generate the plot with any new set of data. So now if you want to generate your own figure, you'll do it by writing create figure, the same function name which is there, create figure, and the variables which you are working on, that is day of year, year, soul ratio, and with respect to soul ratio. Now the question arises, this is the same picture we were working on, or for which we were talking about. This particular square bracket is, if you can see over here, this S1 asks the size of the figure, and we don't need to specify it right now. So we simply say use a default one and put a square bracket on its face. And you have just saw that. Oh, sorry, screen share. How can I forget? Okay, when you clicked on that your statement, this figure just popped up, and this is the same figure you were working on. This one, the same figure has been popped up by using command in MATLAB. So now, in spite of coloring according to your Z value, I want to color each point in a fourth variable. That means I want to plot each X, Y, and Z values according to average relative humidity, which I know is not a part of XYZ. That's why I'm saying that I want it to be plotted with respect to the fourth variable. So if I want to do that, what I'll do, I'll basically write the same command, but rather than writing with respect to soul ratio, I'll write average relative humidity. And if I'll enter it, I'll see there is a new chart which has automatically generated for us. And if you can, yes, we'll like go on 3D. Oh, new screen. Wait. So when you just wrote average relative humidity, then this particular figure just popped up. This one. Okay. And here you can see there was a high solar ratio, where there was a high solar ratio in the middle of the year. There is a low level of humidity now. So this is the best way to analyze the data, and can even analyze it on a new data set that we can come across as per our need. Now suppose at this point we realize that we need some additional information to complete this analysis. Maybe some additional information from same spreadsheet or some from new spreadsheet. Like for now, I have an information from that Excel sheet Davis, but what if I have an information from other stations too? In that case, let's go to the import tool and we'll add some additional columns to it if I want to. But adding multiple data from different files make it complex. So although I'm not going to add different files for now because it will be more complex thing for you, but I'll tell you how we can do it. Yes, this is visible. What we did, let's suppose this is the data and I have added, let's suppose I have added new regions, although I don't need it, but suppose we just added this region. So randomly we have added a new one. So I'm disabling right now because this will create a mess for me for completing the example, but you can select it if you want to. So let's suppose you have added new columns for your as per your need, and to remove that confusion, what you can do, you can click on table as per the column vector in the output type and rename it with mm, solar device. So it is a table where you have selected columns as per your need. If you want to add new, you can add. If you don't want to, you can remove those also. So now when I was studying this data, yes, you can see there are some of the missing entries also. So so if I want to remove these entries from not being a part of our model, so how I can do, I can just go onto the unimportant cells and I'll click on exclude rows with. So if you will see, its value has been turned to purple. That means now this will be excluded from our model. So now we'll automate by creating a function for this, and we'll click on generate function, and the function has been generated for creating a table for our the new table which we want to create. So we'll save it, and okay, so now basically table out is to have any output function, import file is the name of the function, and everything else is your some input in your brackets. So now our output is table solar device, and for generating table our commands will be solar device is equal to import file, the same function which is there. You are not supposed to change this. If there is 1 2 3 xyz, you have to write that also with it. Import file, and then device daily dot xlsx. Yes, so we have to wait for this for a while. Yes, if you can see in the workspace, a new entry has been added with a table, which is a table, and that too with the reduced number of rows and the number of columns we have selected. If it's 8, then it will be 8. Okay, now this is a very amazing tool. Like we have just automated, you can do that also. So now let's open a table. Where it is? Yes, here it is. We'll open it and wait for a while. New screen to share. Okay, when I just click on the table from workspace, this particular some of the things has been automatically added. So it was date, day of the year. Soul ratio, max, min, average. I think something has happened. Issue. What were the elements we were working on? Okay, we were working on date as well. So where is my date? And okay, so I have date, day of the year, soul ratio, max, min, and yes, these are the things which we're working on. So now, if I want to plot a data, I'll simply can go and click on the particular column I want to work in, and we can see we can have a simple chart, a histogram, but definitely I have to screen share it. Will take time. Okay, anyways, it's a signal that we have to complete our session a bit faster. So I'll skip those all unnecessary things and directly come up with the important work. So where I was, now I have to do. Okay, now we'll automate our excess space. For that, what we'll do, we'll go back where we were, but now with the data table and try with the new data table, and we'll try to run our previous commands that are your year, and date, vec, and that too with solar device right now, solar device, and we want date. We want date, and just a quick check. Are we right? Okay, so we have to wait for a while and see. Yes, the rows of our year in the workspace, if you can see, the rows of the year variable has been reduced.
Dr. Bhavneet,
Yes, ma'am.
actually, sorry to interrupt you. Our next session already started. So is that possible? Whatever the pending is there, then we will do in a next session, because already second session has been started. So
Yeah,
if
ma'am, it's completely okay. Don't worry. It's completely okay with me.
okay, thank you so much. Dear research scholars, if you have any query, then you have to just give up on a chat box, and we have share one link for the feedback form. So you have to put it your feedback form with your screenshot. After that, we will give you the mark your attendance. And Dr. Bhavneet saying thank you so much. Your session was very informative, and I'm sure that next session we will continue with you, because our research scholar I get lots of knowledge, and even for our CSC also we will do a one session for MATLAB for you. Thank you so much, ma'am, for your valuable time.
Oh, that's very nice. Nice of you, ma'am. It's completely okay. I hope they learn something new today, and definitely if I'll get a new continue session for any other time, we'll complete that particular thing because it might be very interesting. But the person who was like in a query of how to import data from Excel, maybe his query has been resolved.
Thank you so much. I will share the query.
Yes, ma'am. My query is resolved. Thank you, ma'am, for that.
Oh, it's okay.
Thank you so much, ma'am.
Okay, ma'am. See you.
Thank you
Bye
so
bye.
much,
Have
ma'am. Thank you so much.
thank you, sir. Have a good day and a good weekend.
Thank you, ma'am.
Bye
Thank
bye.
you, ma'am.
Arul, are you there?
Yes, ma'am. I'll be around.
Yes, kindly off the session.
Okay, ma'am. Ma'am, and inform to Dr. Manoj Shanti also.
Yeah. I'll inform. Thank you so much, Arul, for
Thank
your
you. Thank you, ma'am. Thank you.
Ma'am,
Yes.
ma'am, you
Thanks,
just
Dr.
mentioned
Bhavneet.
that we have got a link for the attendance. We only got a link for the attendance. That was the same form for feedback also.
Yeah.
Yes. So all of you will please
Okay.
fill the feedback form. Only then you will get the attendance. Okay.
Okay. All must have to fill that feedback form, beta.
And sir, I stopped the recording. Naresh, sir.
Yes.
Sir, I stopped the recording, and the recording is stored in the cloud storage in our
Okay. And
Galgotias University.
all scholars immediately join their respective classes. Information I have shared on WhatsApp group. Okay. So today there are domain specific classes.
Hello.
Okay. Yeah.
Sir, where is feedback link?
Excuse me, I am share the feedback form through mail and as well as in the group also.
Okay, sir.
Yeah.
Okay. Thank you so much for all of you. Thank you.
Thank you, ma'am.
Thank you, ma'am.
So may I end the meeting?
Yes.
Yes.